Hi, I welcome you all to my video lecture series in which I am doing payload questions from Keith Williams. In this video lecture, I'll solve next questions from payload chapter and show you all how to do these questions with detailed solution and explanation. With this, I expect that you will be able to understand and do all payload questions whether they come from Oxford, RK Bali or Keith Williams in your exams, any other entrance test that you are taking. So let's begin with today's question number 96 and finish this chapter, Payloads from Keith Williams. Question 96. Aircraft has four engines, each of which consumes 1000 kg per hour. Now this is a type of question which we have done many times before. So this question is no different. It's very similar to them. And then they have given us other conditions. We have to find maximum traffic load. We stick to our basics, that is step 1 and step 2. In step 1, we'll make three columns, one for takeoff mass, the second one for landing mass, and the third for zero fuel mass. In the takeoff mass column, you write a value which is lower of performance limited takeoff mass and structural takeoff mass. Performance limited takeoff mass is 62,800. Structural takeoff mass is 64,800. 62,800 being less than 64,800, it becomes our takeoff mass choice, our choice of takeoff mass. So 62.8. In the second column, we have to make a similar decision between landing mass, that is structural landing mass, and performance landing mass. The performance landing mass of 50,000 kg being less than maximum landing mass 56,000 kg. 50,000 kg becomes a choice. That we add trip fuel. Okay, to that we add trip fuel of some value. Now that value is not given to us directly, we have to find that out through some other way. They have told us this aircraft has four engines, each of which consumes 1000 kg of fuel per hour. Diagrammatically, this is my representation. So every engine consumes 1000 kg of fuel per hour. So for a 3-hour duration flight, every engine will consume 3000 kilogram of fuel, 1000 kilogram per hour. So for 3 hours, it will amount to 3000 kilogram. Now your trip fuel will be equal to total fuel consumed by all four engines for that duration of flight, which will be 3000 plus 3000 plus 3000 plus 3000. So 3000 into 4, which is equal to 12,000 kg. So add 12,000 here and you get 62. Next, zero fuel mass plus fuel on board. Zero fuel mass is 51,300 or 51.3. Fuel on board or takeoff fuel is nothing but total fuel in your fuel tanks when your aircraft is situated on the ramp. That is nothing but your ramp fuel minus startup and taxi fuel. Ramp fuel is 25,778. Startup and taxi fuel is 350 kg per engine. So for 4 engines, it will be equal to 350 into 4, 1400. Before I proceed, I want to make one point clear. There are two types of RAM fuel given, RAM fuel only and maximum RAM fuel. The maximum RAM fuel here denotes or tells us the maximum capacity to which you can fill the fuel tanks when your aircraft is on the ramp. Okay, it's just the limit. The reality, the actual fuel that you are filling in the fuel tanks when your aircraft is on the ramp may be equal to that or maybe less than that. So doing this calculation, you will select the actual ramp fuel. Okay, the fuel actually in aircraft fuel tanks when it is on the ramp, which is 25,778. Don't select this. It is nearly a limit. Okay, so don't get confused between them. Now 25,778 minus 1,400 is 24,378. 24.378. 51.3 plus 24.378 is 75.678. Now out of these three values, you have to select that value which is the lowest of them all, and that value is 62. So 62 becomes a regulated takeoff mass. Payload is unknown. Dry operating mass is given here 26,372. So 26.372 plus fuel on board 24.378. Therefore, payload will be equal to 62 minus 26.372 plus 24.378, which is 50.75. That is equal to 11.25. So payload equals to 11,250 kg. Okay. Option delta, 11,250. Next question 97. Aircraft is to conduct a flight for which takeoff fuel load is provided to you. Then 4 crew of mass 95 kg, basic empty mass is there. Performance takeoff mass is there. Special equipment load is there. Again, another formula based question. Let's substitute the values. Takeoff mass is 227. Dry operating mass is not given to us directly, but we know dry operating mass is basic empty mass plus variable load. A basic empty mass is 100.55. Fuel on board is 33,750, 33.75. Next, variable loads. Now, variable loads include special equipment and crew load. Special equipment is 8.55 and crew load is 95. So 4 into 95, because there are 4 persons each weighing 95. So 4 into 95 is 380, nothing but 0.38 plus payload. So payload will be equal to 227 minus 100.55 plus 33.75 plus 8.55 plus 0.38, which is 143.23. So this subtraction will yield us 83.77. So the payload that you can carry is 83,770 kg. Okay. Option delta again. Simple. Question 98. Similar question. Regulated takeoff mass is DOM plus fuel plus payload. Okay. So we will directly skip to this good part. Regulated takeoff mass is 2,27,550. So 227.55. DOM is basic empty mass 112.5 plus special equipment 9.55 plus crew. Now there are 5 persons each weighing 98. So 5 into 98 is 490, 0.49. Fuel on board is 32,500. So 32.5 plus payload. Therefore payload will be equal to 227.55 minus 112.5 plus 9.55 plus 0.49 plus 32.5, which is 155.04. So 227.55 minus 155.04 equals to 72.51. Nothing but 72,510 kg. Question 99. Aircraft is to conduct a flight for which takeoff fuel load must be so and so. How much traffic load can it carry on this flight with 12 crew of average mass 95 kg? Basic empty mass is given and cargo is given and is field limited by performance limited takeoff mass. Now we all know that Performance limited takeoff mass will be equal to DOM plus fuel on board plus payload. Takeoff mass is 220. Dry operating mass is basic empty mass plus special equipment plus crew. So there are 12 persons weighing 95 kg each. So 12 into 95 is 1.14. Fuel on board is 39,700, so 39.7 plus payload. Payload will be equal to 220 minus 98 plus 11.95 plus 1.14 plus 39.7, which is equal to 150.79 minus 220 is 69.21 or 69,210 kg or 69,210 pound. Next, question 100. Aircraft is to conduct a flight for which similar conditions similar to previous question. So again we will substitute the value. Takeoff mass is 215.5. Dry operating mass is basic empty mass plus special equipment plus crew 9 into 95 0.855 plus fuel on board 34 plus payload. So 215.5 minus 109 plus 8 plus 0.855 plus 34, which is equal to 63,645. So payload is 63,645. Option C. Next, question number 101. Again, what is the maximum allowable traffic load if takeoff mass, zero fuel mass, landing mass, DOM, fuel, trip fuel are given to you? The takeoff mass is what? 167. Okay. Landing mass is 108 plus trip fuel always basics. So 108 plus 33 is 141. Zero fuel mass is 102. Takeoff fuel is 37.5. So 102 plus 37.5 is 139.5. Now out of these three values, you have to select that value which is the lowest in all. So that value is 139.5. It becomes our regulated takeoff mass. DOM is what? 63. Fuel on board is 37.5. We'll find traffic load. So traffic load will be equal to 139.5 minus 63 plus 37.5, which is 100.5. So traffic load will be equal to 39.5 or 39,500. 139.5 minus 100.5 is 39,000. Correction. So answer will be 39,000. Option delta. This is how you do this question. Very simple formula based. Next, question 102. What is the maximum allowable traffic load if these conditions are given to you? Now in the takeoff mass column, you write the takeoff mass value, which is what? 175. In the landing mass column, you write the landing mass value 110. Add trip fuel, which is 34. So 110 plus 34 is 144. Zero fuel mass is 122. Takeoff fuel is 39. So 122 plus 39 is 61. Now, out of all these three values, 144 is the lowest, so it becomes our 144. So it becomes a regulated takeoff mass. Dry operating mass is 65,000 or 65. Payload is unknown. Fuel on board is 39. Therefore, payload will be equal to 144 minus 65 plus 39, 104. So that is equal to 30. Correction 40. So payload will be equal to 40,000. Option A. So this is how you do this sum. Next, question 103. Variable load is basic empty mass minus zero fuel mass. Wrong. Variable load is equal to dry operating mass minus basic empty mass. Traffic load is zero fuel mass minus. Wrong. Absolutely correct. Variable load is, again, this is wrong. Operating mass is zero fuel mass plus fuel. That is right. So options 2 and 4 are correct. Okay, so mark that option which contains these 2 points, point number 2 and point number 4. With this, we come to the end of this lecture, and we also have come to the end of this payload from Keith Williams question series. I hope you have liked all the video lectures that I have solved. You are you have understood all my solutions. You have understood the method, the process of answering these questions. If you still carry any doubt or question, let me know in the comment box. I request you all to like this video lecture, subscribe to this channel, and most importantly, share this video with all your friends. Thank you for your time. I wish you best of luck, and I'll see you in the next video.